Okay, let's think. Top minus bottom, bigger minus smaller, right minus left, bigger minus smaller. Okay, so same concept, except now we're going right minus left, which means our functions need to be in terms of y. Okay, if you can imagine, so don't write anything down. Yes, I was getting there.
Turn all the lights on. Yes, please.
Yes.
Okay. I'm tired of being bossed around here.
Please turn all the lights on.
I don't think we need to. Stop writing for 1 second. I want you to look at this picture. If we put in a reference rectangle that is horizontal, okay, the length of that rectangle, the more positive part is on the right, the smaller function is on the left. So the height of this rectangle is right minus left. The thickness, since that thickness is perpendicular to the y-axis, that thickness is dy. So we're going to add up all of these infinitely small rectangles with thickness dy, which means we're integrating with respect to y. Whatever you want to write. If you don't want to write anything, then don't. Okay? But do you see the difference in our rectangles? Y, the vertical one is dx, y, the horizontal one is dy. Okay? These are all lining up against the y-axis. Those thicknesses are along the y-axis, and so that's why it's thickness dy.
From our limit integration to the top bottom.
Right. Well, we still want to go smaller number to bigger number. So notice how our limits of integration are from C to D. We're still going to go in order from least to smallest. Okay? But everything has to be in terms of y. Our limits of integration are the intersection points, but the y. And then our functions have to be in terms of y. Okay. So this is kind of a nice, thank you for asking about this problem, Jimmy. Even though you didn't need to. But then we went through it anyway. We used two different integrals on this problem, right? Now let's imagine, and those of you watching at home, I'll do more examples, don't worry. If we put in rectangles that are horizontal with thickness dy, how many integrals will we need for this problem?
All of them. So three?
One. Because we can go from y equals 0 to 2, and the function on the right is this one, correct? So we would have to rewrite that as y equals 0 to 1. Oh, thank you, 0 to 1. Okay? We would have to rewrite this as x equals 2 minus y. And so the function on the right is 2 minus y. The function on the left is y. dy. And now we have it with one integral instead of two. More convenient. Because our y values that we have begin at 0 and end at 1. Oh, okay. So write these equations down. And then, thank you for asking that, because this was an example I would have done with you yesterday had I been here. And this would have been a nice comparison for why this would be convenient. Okay. know how much Mr. Dribble stressed yesterday, but you have to have a picture every single time.
He said never draw a picture.
He says if you're drawing a picture, you're on the wrong track here, but
I don't believe so.
Well, he said it kind of fast, but it did sound like that.
yeah, so.
Okay. I want a picture every single time. And I want a reference rectangle every single time, whether it be area or what we do next week. Okay? So, here we go. X equals y squared. Okay? So y equals square root of x, y equals negative square root of x. Okay? And then y equals x minus 2. I don't think I have to go through. Okay? So we are talking about this area in here.
Well, that's pretty sweet.
Whoa, time out. How did you do that?
It's called a highlighter.
Oh, that's fancy.
Fancy.
You can use crayons? I'm actually doing this in crayon. Come on, let's do the rest of the class. Do it. Do it.
Stop bossing her around, guys.
Do it. No, please
Thank
do
you,
it.
John. All right. So you can see that if we were to make vertical rectangles, our function on bottom would switch, right? However, we make horizontal rectangles with thickness dy, our right function stays consistent and our left function stays consistent.
Like for the first one, would you put it over itself? If you wanted to do the integral from the axis. Really remove the intersection point.
But we'll talk through it after notes. Okay? Because I think I know what you're trying to say.
What would you do with the dx?
Like, it would have to be square root of x minus negative square root of x.
Oh.
Square root of x minus x. Okay? So this is the function. We're going to have to write it as x equals y minus 2. And this is the function x equals y squared. Okay? Your functions need to be solved for x so that they can be in terms of y. Okay? Now what do we need to know about these? Where they intersect. Okay? Here's my warning to you. Can you sometimes look at the graph and be able to tell where they're intersecting?
Yes.
Yes, but what should you do before you...
Equals usually.
Okay, check. Okay, if you look, I like that you want to set them equal to each other. That will work 100% of the time. Okay? But if it's a graph that's very simple and you think that you can just look at their intersection points, make sure you check to make sure they actually work. Okay? But we'll go with, let's set them equal to each other. Something happened.
Yeah. Yeah, you have to set the x's at the same.
You didn't catch my algebra mistake right here.
Yeah,
Right? If I add y over, or add 2 over.
I didn't want to boss you around.
Okay. So we have y squared minus y minus 2 equals 0. What does that factor to?
2 and y plus 1 Yeah, that's right.
Which means y equals negative 1 and 2. So for this integral, we intersect down below at y is negative 1. We intersect up top at y equals 2. Our very right function is y plus 2 minus our very left function is y squared.
Can we still math 9 minutes for the chain?
Okay, that's a great question. Thank you, Zach. You can still do this in your calculator by using Math 9. your calculator is going to say X, right? Because that's the variable your calculator has, but you're still doing the integration in terms of Y, okay? Whether this was T's, X, Z, W, F, whatever it is, your calculator is going to have, your calculator has Y's, but theirs is going to say X,
Okay.
okay?
Wait, so you can still graph it even if it doesn't have that term in it?
Well, you can still say math 9 even though you type in X.
So you would have to write X plus 2
I
minus
just keep X squared.
Right, so you would have to type in X plus 2 minus X squared dx, and it's going to give you a value, okay, that's going to be the same as this.
You get 4.5 by that.
9 halves.
9 halves, 4.5, whatever you say, it's going to be fine.
Equals is always
You want to do the fractions? That is true. Let's get in the habit of fractions, because when we get to next week, we're going to have, like, a pi thrown in there, and I would not want 4.5 pi.
I like that.
I would want 9 halves pi. We'll celebrate Pi Day.
Hey.
What kind of
Oh, that's right.
And then we get a karaoke day after. Oh, I wrote that down.
Yeah, karaoke.
Karaoke day after the AP test.
3.15.
Is that what Mr. Grable told you?
That's what you told us.
I did not say that.
You did? Yeah.
I said karaoke day.
Oh, yeah.
Why would he write it down?
Just only write down karaoke day.
I mean, it's faded.
It was the day you wore that soccer uniform.
Oh,
From the big boy.
perfectly green.
Oh.
Okay, next example. All right, now we have to graph these. We're going to have to think a little bit of how these graphs are going to look.
You know how the first one looks.
Turn your paper.
This with the right. Counterclockwise.
Not convinced.
No, counterclockwise.
Clockwise.
Clockwise.
Let's graph it, and then I'm thinking one thing may be backwards if you try to do that. Okay.
The 10.
All right. So negative y squared plus 10. What does negative y squared look like? The parabola that opens to the left, plus 10 would force it to go more positive.
Yeah, it's huge.
Okay. X equals y minus 2, the quantity squared. Okay, so if we were doing this, okay, it's a parabola opening right, shifted more positive, right? If I plug in y is 2, x would be 0. Do you agree? X is 0, y is 2. So I don't think that will work.
You're negative for y.
Oh, grand. Oh, yeah.
So this is our area. Okay. Now, I want you to just imagine trying to do this with vertical rectangles. How many integrals would we need?
1, 3.
I think 3.
2, 3.
Because it would switch here and here. So 1, 2, 3 integrals. Either way, too many. Right?
That's counterclockwise.
No. No.
Okay, so we want reference, oh, this is totally just not even.
There you go.
Yeah.
Yeah.
Is that crayon?
Yeah.
It tells you what's up. Wait, there's magic pen.
There is a magic thing. Okay, so we want rectangles that are horizontal, that have thickness dy. Okay?
Oh no.
So we need to know what those y coordinates are. Okay? All right,
So
that was it.
If you did it the other way, you would need three different intervals.
Yeah.
How come?
Because the function that is on the top switches here. The function that is on the bottom switches here. So this top minus bottom is different than this. Top minus bottom is different than this.
You have to subtract itself.
Well, remember when you square root both sides, you get plus or minus. So one of them is a positive radical and one of them is a negative radical. So you're subtracting the opposite of it.
Let's just do the
Okay. You're solving these intersection points for me, right? What are you going to have to do that right side? Because if you, yeah, did you come to one square and make it plus this? I heard a -1 and a 3. Anyone having issues getting that? Okay, did you move everything to one side? What?
Oh yeah.
Don't do magic.
Yeah, what's magic pen?
What's
Can
magic
somebody
pen?
come up here and touch this?
No.
So 2y squared minus 4y minus 6, right? We can divide by 2.
Three.
Divide by 2. Okay? So then we have y times y gets us y squared. -3 times +1 gets us a -3, and that will add to be the -2y. So our intersection points, I don't care where the x's are, we care about -1 and 3. So our integral for our area, integral from -1 to 3 of which function is on the right? -y squared plus 10 minus what function is on the left?
The other one.
dy. Now let's talk about if we had to do this by hand, you would have to FOIL out y minus 2 the quantity squared, apply that subtraction to it, combine like terms, and then go through the integration process.
Ew.
Okay?
It's not.
You wouldn't.
Oh, you.
Why can't we do anything respect to mine? Because that's pretty true.
Nathan, are you plugging this into your calculator?
Yes.
I got 21 and
She
1
got it
third.
right this time.
Rational.
64 thirds.
A lot of thirds.
Anybody having issues on that calculator?
Dude, what's your social security? What's your social security? No.
Well, let's see how you answer the question. What's your social security number?
Yeah, everyone
Okay.
has.
One more problem to make you think. Of course I know it. Get it? Brady, you doing okay with that? Not necessarily. Zach asked if I needed to put this first function in parentheses. Not really. It's really the second one that we're subtracting. If you want to get in the habit of both, that's fine. Okay? Oh. Okay, so sorry, that's kind of small. So this is our last problem. Find the number b such that the line y equals b divides the region bounded by y equals x squared and y equals 4.
Regions.
Two regions equal area. Like action.
So what are we dealing with here?
We're dealing with a graph.
Here's y equals x squared. And y equals 4. Okay? So we have
Magic pen. No, magic pen.
magic pen isn't going to work for us.
You don't know that.
It's magic, I'll tell you that.
It's like a wand. Wand.
We want to find another line that is horizontal.
Okay, so y equals b. That's just some horizontal line, we don't know where, that's going to divide it into two equal regions.
Yeah, you have to set two integrals equal to each other and solve.
Okay, say that louder.
To set two integrals equal to each other and solve.
Okay, we have to set two integrals equal to each other and solve. Now, what kind of integrals will be helpful?
Because you know it's 0 to 4.
Okay, what we could do is we could set up two integrals, one that goes from 0 to b, and one that goes from b to 4. Okay, so we, what?
What are you supposed to determine right now?
Okay, let's talk about that. If we're going to go right minus left, then we need to solve this equation for x. So if y equals x squared, then x equals plus or minus square root of y. So this function is square root of y, and this function is negative square root of y.
I just got a crazy idea. Can't you just find the whole area and divide by 2?
But, so find the whole area divided by 2, and then do what with it? Because we need to know where it's going to hit that halfway point. Okay? But you can do that and set it equal to the integral from 0 to b. So this is what Nathan suggested. Okay? So the integral from 0 to b needs to equal the integral from b to 4. Okay? So our area from 0 to b, right minus left, radical y minus negative radical y. Okay, so 2 radical y dy. Okay, so what's the antiderivative of 2 times y to the 1/2? We're gonna have,
Y.
okay, so I'm gonna, hold on, I'm just gonna write it like this.
4/3 y is equal to 3/2.
Okay, what'd you say, Carter?
4/3 y to the 3/2.
4/3 y to the 3/2. On this left side, we need to evaluate from 0 to b. Same antiderivative over here, but we have to evaluate from b to 4. Okay. So when we plug in b, we get 4/3 b to the 3/2 minus we plug in 0.
0.
Over here, 4/3 times 4 to the 3/2 minus 4/3 b to the 3/2.
32/3 minus.
Okay, so this is 32/3. You're telling me. And if we add this over to join the other b to the 3/2,
8/3.
Can't you divide by
You can get 4 equals b to the 3.
So you have to,
8.
you have to square root it. And then,
What did you just do?
okay.
okay, so up here we took this and we combined it with this b to the 3/2 to get here. Then we can divide by 8/3 or multiply by 3/8, so the 3's cancel. We have 32 divided by 8 is 4. Okay, then to get rid of the 3/2, we can take both sides to the 2/3. And there we go. Make you think a little bit.
Would you want that in decimal form?
Nope. Okay. So I believe you will have a problem similar to this in your homework. Okay. I've already been asked, do I want them in this weird order? Yes. I want 15 to come after 25 to 27 because 15 is going to ask you to compare the 2 different methods, dx and dy. Okay. So, by hand, I would like you to do 25 and 27. 25 and 27 you can do by hand. Everything else you can do with a calculator. Sound fair?
Sure.
I circled one little crayon.
So,
Or magic pen. Magic pen.
Okay, you want me to show you what the magic pen does?
Yes.
let's wait for them.
Wait, let me change colors.
Oh, that's scary. Yeah, what's magic about it?
That's false.
Whoa.
Well, how do you get it back?
You don't.
Yeah, you do.
Sure you do.
You don't. It disappears.
You don't. And it'll.
No,
I'm in
no,
the
make
4
more.
class.
Yeah. You can write secret messages.
Okay, and then I can do this.
Oh.
Okay, so that wasn't a good example.
What is that?
Okay, so watch this.
What?
What?
Sheboygan.
Why don't you just change that?
How would you use that?
What? Wait, not a circle. What? Oh, that's fun.
Oh, yeah.
Why don't you use magic?
That's the little word.
Is this a recording?
Yeah.
That's like Patrick.
Now you get him.
Because it does look like Patrick. It looks like
He's got that one
Because
lazy
he's
leg.
a starfish.
Going lazy leg.
What are the other things? Yeah, like, hey, can you go back on one of those?
Wait, no, look at